Hi everyone. This week we're gonna do something different, and because I've been shopping a talk around,
Welcome to the dangerous side of Kotlin.
and Mikola happened to see that talk, and so he had some feedback that we're gonna put all out there. So we're gonna go quickly through the points of that I make in the talk, and if you want to see it, we're gonna put a link in the description. Um, to There's a couple one.
The one which we like the most.
Exactly, exactly.
So your first dangerous side was extension functions, according
Yes.
to the video, right?
Yes. The main idea of the talk is that Kotlin is really awesome. It provides you all kinds of powerful tools, but with great power comes great responsibility, right? Powerful tools enable you to do wrong things really powerfully. And I highlight a couple of features in the talk that I think that are really easy to apply wrongfully in a powerful way. And extension functions is one of these first things. It's really powerful for making semantic code in a local scope, but it really breaks the inherent encapsulation that objects provide, in my opinion. And that is the risk that I see in them, that you can create, for example, an extension function on a base class or a base type, and then you, before you know it, you have that same or a similar extension function scattered around that doesn't really work with other types of extension functions. And maybe you're importing one in several places, but in other places you have it private. So it keeps the concept behind the class entirely opaque to the code base, and I think that's a risk.
Okay, so what I hear, the dangers are breaking encapsulation and scattering around. Let's start with the last one. Basically, the last one is nothing new with the functions, because extension function is a function that's attached to this, that gets implicit this. So if you look on the traditional functions that we used to have in Java, for example, more or less, or just simple functions in Kotlin, you would have the same problem of scattering, that you might re-implement the same function in different places with slightly different ways. So I guess it's not really anything new for the
No,
extension function, is it?
it's not new, but the fact that you're modeling that function as an extension function is a clear indication that maybe there's a concept there that you're missing.
Well, that can be. Then we can maybe come back. Why do we want to use the extension functions? But before that, I also curious how does it break the encapsulation? Breaking encapsulation would mean that I can have access to something that a normal function would not. And I guess that if I am outside the module, I am not in the same class, then I would not have access to the private members of the class. So I don't think it really breaks encapsulation, does it?
I think you're right. It's not really breaking encapsulation.
What I think it gives a danger, maybe that's what we were saying.
Right.
For me, when I'm in Java, without the powerful extension functions, I know that if the method is attached to an object, it comes from that object, from the class, from the people who designed the class, from a module, especially if it's a library. Whereas if the function is in my utility, that's a different story. Then I have different expectations, basically. Whereas when I'm going to Kotlin, now I lose this simple way of judging where the thing is coming from. I need to know, okay, I have in the code somewhere object dot do something. Okay, is this do something? Is it just in this my module, in this class? Is this my helper function of varying degree of quality, or is it coming from this very high quality library? I'm not sure whether you meant this one, but that's one of the dangers, well, inconveniences that we're getting with the flexibility that I see.
Yeah, I agree with that one, but it's not the one that I was really talking about. It's more like you're putting extra distance between your local scope and the definition of that scope. Does that make any sense?
You
So
mean that your local scope becomes a little bit broader because of that? Because now extension functions are also part of that.
well, I'm talking about the local scope of the extension function. That is basically scoped to the object that is remote, essentially. And
Yeah, but when you are in extension function, okay, so here we're talking about two different things, because I was mostly talking from the outside. So if I'm using the extension functions or I see the extension function, that's where the danger is for me. Because when I'm in an extension function, I assume, after some experience working with them, you will clearly see that, okay, this is a prefix, so I am inside this function. So for me, that's not a big problem. I know that I'm inside an extension function. Or maybe you mean something else different again.
yeah, no, I just realized I'm now confusing extension functions with lambdas with receivers. It's
okay, we will cut it out then. Don't worry.
Sorry.
And the example you're giving for lambdas with receivers, what you're explaining why it's a problematic, because actually you're combining those two again. You have an extension function attached with a lambda with receiver, and you are using it. So
yes.
different things all summed together.
Yes.
Which is another problem with Kotlin. We have many new shiny things we like to use and combine.
Yeah.
But back to extension functions. So scattering is a problem. Part of the scattering, from what I heard from you, is that potentially something is missing in the original class design or implementation.
Yeah.
Maybe. Okay, I can argue with both of this. So with scattering, I already said it's not a different problem as with just the normal functions. So I don't really see this as a problem. As long as I can quickly see where my extension function is defined by one click, preferably, then in my IntelliJ I can live with that. So far I haven't had much problem with that. About missing concepts in the original implementation, sometimes I agree, sometimes not. First of all, we can have libraries or stuff that we get from somewhere else, even not Kotlin, so we might want to extend it. Second, where I see it used, and it can be dangerous, but it can also be convenient when we want to add something that is not related to the scope where the original class was defined. Like if we are working in the hexagonal model, your domain entities probably don't want to know about the details of serialization, deserialization. And yes, you can model those serialization, deserialization other ways, but sometimes it's very convenient to model them via .to JSON or something like that.
I definitely agree. But that is a coherent set of functionality that makes sense on the object only in that scope of that serialization code. So that is exactly where extension functions shine. You have an extension to an external class that is specific to your local use case. So that I think is a perfect use case.
Okay, so you're not arguing about it. I just want to clarify this. Okay,
no, and
so
I'm definitely not saying never use extension functions. I'm saying be aware that you run the risk of hiding better solutions.
True, and again, coming back to this can also be a technique. Sometimes I can add the extension functions or utility function, but in this case, extension function, because I'm not sure whether it's generic or not. Even though I can move it to the main class, but maybe this is one case I don't want really to pollute my class, my original class. So that can be a technique.
And also, what I wanted to say about what you were saying, this is not unique to extension functions. I think that is basically true for all the features, because none of these features add like conceptually new things. Most of it is actually just syntactic sugar to things we could do with almost any kind of programming language. So none of these problems are unique, I think, to Kotlin.
Well, that's definitely not unique to Kotlin, but some of them are becoming much more dangerous and acute when we're switching from Java to Kotlin.
Exactly.
And I think for the scope of this discussion, it's better to say, okay, say we have Java and starting to use Kotlin, or thinking whether to use Kotlin or not, what can be the dangers there, or just using Kotlin without anything. The next point from you was operator overloading. So basically your point, the danger there is that something that can be very obvious for you when you're implementing it and very convenient can be very surprising for other people, because it might not be necessarily either properly mathematical operation or what they would expect from this particular operator. And yes, I would definitely agree. I think operator overloading can be very powerful, but one of the things that you want to keep it and not to suffer from it, you should use it really, really rare, for only when it really does make sense. Luckily, at least in my experience with the team I worked, it hasn't been much abused. So most of the time we would use those things that are coming from the standard library of Kotlin. I really like 2 of the pairs, especially for flexibility of testing and building maps and so on.
But that's an infix, right? That's not really operator overloading.
Is it? Oh, it's not operator overloading.
But yeah, I like it too. I think it's a good way to create.
Same stuff for me.
Yeah,
but
yeah,
that's true. That's infix. I slightly confuse them, but what I have a little bit of a problem with operator overloading is one very specific invoke operator overloading.
Right. Okay.
And that's
yeah.
which I myself actually started to abuse at the very beginning very, very much, because I really like the idea that I can define a class which will be my service, very small service specific, not a huge old school service that does everything and facades repository behind. No, specifically dedicated for doing something. And then because it's with a specific function, I don't need to have a method, or I will have internally a method, but when I'm calling from outside, I will just say this service and then invoke it. So I'll just do it with the braces, which I found cool.
Yeah.
And it worked. Unfortunately, it started at some point to break the clickability, which is a very important feature for me. So at the beginning, when I started to use, if you position your cursor properly in IntelliJ, you would be able to jump directly into the invoke implementation. Now, for some reason, it's not possible. So you will jump on the field, then you need to go to class, find the invoke, and that's really annoying. And I worked with the teams that were very strong into using these invokes, and it was a very frustrating experience for me.
Yeah, basically you have to reteach yourself to open class instead of command click when you want to find that, but that is only applicable to the classes that use this invoke. And thank you for highlighting this, because I went through exactly the same journey.
Yes, and it brings 2 points. First of all, the importance of clickability in general, not only Kotlin, like things like annotation-driven development, too much magic in Spring that sometimes we're suffering. I think it's important to be able to quickly and efficiently jump into implementation and see what's happening. So when it's getting broken, I'm not happy about it. And another thing is just in the team dynamics, some things might be cool and very useful and convenient, but if there are side effects like what we are discussing that really frustrates your team members, like me, sorry. please be merciful to other people. While editing this video, I noticed that it is possible with IntelliJ to jump from invocation to implementation. For that, we need to command click on the closing brace of the invocation. Then you jump straight to the implementation. You still have to be aware whether it's a function or an object pretending to be a function, but better than nothing.
One more thing that bugs me about this invoke overloading is if you do that, then it seems to be really nice because you have like a first class function. It's an object that is a function. Makes total sense. But then it actually does not implement a function reference, a function type. So if you have an interface that accepts a function type, you cannot pass an object with an invoke function as a reference to that function type.
Well, you can, but then you need to remember again and say object to colon
invoke. Yeah, exactly. You need to pass a method reference to the. As I was saying this, like, wait, you can probably do that. So, but I didn't think of that when I used it, and that makes it extra not usable to me.
I think that can be argued by some people who use Kotlin that it would not even be idiomatic to pass the Kotlin reference. I am not supporting this idea, but many people prefer to use lambdas even when they could have just passed the function reference. That brings us back to the idea that by getting this nice, very useful in some cases, very useful flexibility, we're sacrificing simplicity of reasoning. Like early, if you have function, you know this is a function. Now you don't know. It might be something with invoke. And maybe it's not a big deal in this with invoke. It's mostly small annoyances, a couple of extra hooks. With extensions, it's a little bit bigger. With lambdas as receivers, it can be even bigger. So all those things, they add up to the things that you need, micro decisions that you need to make when you're reasoning about the code, where to jump, where to focus, what to look, what are the expectations of this particular call line of the code.
Thank you all for watching, and we'd love to hear what you think about these features, about the dangers of powerful features in new languages in general, and about our comments on them. So please let us know, and see you next time.
Yes, we'll continue with the more dangers of Kotlin next time.
Yes.